Geometric sequence. In today's lesson, we will be looking at what a geometric sequence is and then looking at some questions regarding geometric sequences. So let's have a look at some geometric sequences, shall we, and see what a geometric sequence is. So for example, the sequence 2, 10, 50 and 250 is geometric because a geometric sequence is when the relationship between each term is times or divide. So for example, if I just show you a sequence that is 2, 4, 6, 8 and 10, and that is an arithmetic sequence because you are adding to each time to get to the next term. However, a geometric is when you multiply to get from one term to the other term. So for example here, I am timesing by 5. 2 times 5 is 10. 10 times 5 is 50. And 50 times 5 is 250. That makes it a geometric sequence. Okay, so lots of other sequences like that are geometric. You could even also have a divide one, for example, 90, 30 and 10. How do you get from 90 to 30? You are dividing by 3. 30 to 10, you are dividing by 3. That is also a geometric sequence. So a geometric sequence is where you are multiplying or you are dividing to get from one term to another term. And obviously it has to be the same number. Okay, so what kind of questions are you expected to be answering in your GCSEs? Well, one of them is where you have to work out the common ratio. Now, that word comes up a lot and you might think, what is common ratio? That just means the pattern. Okay, what are you doing? Are you timesing by 2? Are you timesing by 5? Are you dividing by 3 or you dividing by 4? What are you doing to get from one term to the other term? Okay, so for example, we started off at the top with 20, it was 2, 10, 50 and 250. What were you doing? You were timesing by 5 to get from one term to the other term. So your common ratio, which is R, is 5. Okay, or obviously lowercase as well if you want. So the ratio is 5 for you. For example, when we had the other sequence, which was 90, then 30, then 10, then a third, you are dividing by 3 each time, aren't you? So divide by 3, divide by 3, and divide by 3. Okay, and because you are dividing by 3, your common ratio here is a third, because divide by 3 is exactly the same as a third. Okay, a third means divide by 3 in maths. Okay, so let's have a look at another one then. Let's have a look at another sequence. So we've got 80, we've got 20, we've got 5 and 1.25. How do we get from one term? Well, 80 to 20, I know I divide by 4. 20 divided by 4 is 5, and 5 divided by 4 is 1.25. So my common ratio is a bit silly to write divide by 4. We never see that. So rather than writing divide by 4, we are going to write a quarter, because finding a quarter of something is exactly the same as dividing by 4. Okay, let's have a look then with some of the examples that we can do. It's important that you understand what the different letters are. Now, we've touched upon the letter R, which means common ratio, which means how you're getting from one number to the other number. You also have the letter A in the formula. And the letter A just means the first term. Okay, so again, if I go back to the very first sequence that I showed you, 2, 10, 50 and 250, yeah, well, 2 is going to be A. Now remember, we are timesing by our common ratio each time, aren't we? Because 2 times 5 is 10, and my ratio is 5, isn't it? So to get to the next term, I've got to do A times R, which is just AR. Okay, so rather than A times R, I'm just going to write AR. To get to the next one, I've got to times this one by my common ratio. So AR times R is AR squared. Again, then to get to this one, I've got to times this one by R. That becomes AR cubed. Okay. And that is kind of your formula, something that you need to look at and remember. So to work out any pattern then, or any number in your sequence, what should my formula be? Well, we know it's AR, and just have a look. That is my first number, that's my second number, my third number, and my fourth number. What do you notice about the power and the number, which term? Can you see that's the fourth term and your power is 3. That's the third term and your power is 2. That's your second term and your power is 1 there, which is invisible. And that's your first term and the power there is 0, or there is no power. So it's AR n minus 1, because n is your number of terms, take away 1, because that's what your power is going to be. And that's quite an important formula that you need to remember, because it comes in quite handy when looking at geometric sequences and geometric progression. Okay, so you might be thinking, well, what can we do then? How can we use this formula then? So let's have a look then. So for example, you have the formula 3, 6, 12 and 24, yeah? We will work out the 7th term using our formula. The first thing you need to establish is what is your common ratio. So to get from 3 to 6, I'm timesing by 2, 6 to 12, I times by 2, and 12 to 24, I times by 2. So then, if I'm going from one term to the other term, I know my formula is ARN minus 1. I know my first term is 3. My ratio is 2, so 3 times 2. I want this 7th term, so 7 take away 1. That's 3 times 2 to the power of 6. And that will basically work out what my 7th term is. So on my calculator, I'm going to do 3 times 2 to the power of 6, and I end up with 192. So that means the 7th number in this pattern would be 192. What if I was to work out the 15th then, yeah? So the 15th term, so again, it's ARN minus 1. So 3 times 2 to the power of 15 take away 1. Well, that is 3 times 2 to the power of 14. Again, you would use a calculator for this. When I tap that into my calculator, I get 49,152. Okay. Shall we have a look at another example like this, and then we will move forward from this? So another sequence then. Let's have another sequence in here. Let's have a look at 4, 0.5, 0.0625, and so on. So what are you doing each time? Well, to get from 4 to 0.5, let's have a look what we're doing. Okay, I'm timesing by 0.125. And I worked that on my calculator by doing 0.5 divided by 4. And I got 0.125. Just going to check my calculator that if I times 0.5 by 0.125, I end up with 0.0625. Yes, so that is correct. Well, I want to know what the 12th term might be. So my formula is ARN to the power minus 1. My first term is 4. My common ratio is 0.125. I want the 12th term, so 12 take away 1. 4 times 0.125 to the power of 11. So 4 times 0.125 to the power of 11. Oh, okay, so this gives me a decimal answer in standard form. It gives me 4.657 times 10 to the power of minus 10, and I'll kind of round it to three decimal places on my calculator, otherwise the numbers go on forever. Okay, so that gives you kind of a little bit of a insight of what a geometric sequence is and what the letters mean in the formula. So you have the letter A and you have the letter R, and that helps you. Okay, more difficult questions in your GCSEs then are something like this. So second term is 4, and the fourth term in your sequence is 8. We have to find the common ratio. We have to find the first term. And we have to find the 10th term. So we need to answer all 3 questions with just 2 pieces of information given to us, the second term and the fourth term. Well, if you remember from the top there, I showed you what the formula looks like. So we've got the first term, the second term, the third term, and the fourth term, haven't we? Yeah. My second term is 4, and my fourth term is 8. Okay, so I know that the first term is A, the second term is AR, the next term would be AR squared, and the next one would be AR cubed. Now, we know that to work out the ratio in a geometric sequence, you're either multiplying or dividing out you to get from one term to the other term. So if we have a look right to the top, which is here, let's go to this one here. How did I work out that 2 times 5 is 10? I just do 10 divided by 2, don't I? Or 50 divided by 10, or 250 divided by 50. This one here, I did 30 divided by 90, and you get a third in your calculator, which is the same as divided by 3. And then obviously these are the same. Yeah, aren't they? Okay, so to get from one term to the other term, I can divide. So I'm going to do AR cubed divided by AR is equal to 8 divided by 4, isn't it? Well, AR cubed divided by AR, well, the A's cancel, and you know R cubed divided by R is left with R squared. And 8 divided by 4 is 2. If R squared is 2, how do I work out what just R is? I have to square root. So the common ratio is square root 2. Okay, and that's my answer for that one. The common ratio is square root 2. If I do square root 2 on my calculator, I end up with a really long decimal, which is 1.414213562. And we don't want to really be writing all those decimal points out, so we're going to leave it as third format. Okay, so we need to work out some other things, don't we? Now, I need to work out what the first term is. Well, I know that if I'm going this way, I'm going to be timesing by square root 2. But I'm going the other way. So I need to divide by square root 2. So I'm going to do 4 divided by square root 2 on my calculator. So 4 divided by square root 2, and I end up with 2 root 2. And that is my first term. I'm going to write that down there. Then I want the nth term. Oh, sorry, the 10th term. Well, I know my formula is ARN minus 1. I've worked out what A is. It's 2 root 2 times by the ratio, which is square root 2, 10 minus 1. So 2 root 2 times root 2 to the power of 9. Do that on my calculator. So root 2 to the power of 9 times by 2 root 2, and I end up with 64. So that means my 10th number in my sequence would be 64. Let's have a look at one more example like this. So very popular kind of question in your GCSEs. So let's have a look at another one. So second term is 30. Fourth term is 270. We have to work out the common ratio. We have to work out the first term. And we have to work out the 12th term. Okay, so again, I would start by writing 1, 2, 3, and 4. I know my second term is 30 and my fourth term is 270. Okay. So I know my first term would be A, my second term would be A times my ratio, then AR squared, then AR cubed. I know it's geometric, so to get from one number to the number, I have to either times or divide. So to work out what I times one thing by to get the other thing, I have to divide. So I'm going to do 270 divided by 30 is exactly the same as AR cubed divided by AR. Simplify that. So you know the A's cancel because A divided by A is just 1. R cubed divided by R is R squared. And then 270 divided by 30 is 9. I want to work out what R is. So I just square root and I can do this one. It's a nice easy number, which is 3. So my common ratio is 3. Obviously, this means if I'm going from one number to the number, I'm timesing by 3. Well, I want to go backwards, so I've got to divide by 3 then, don't I? So 30 divided by 3 is 10. My first number's 10. Okay, so then I want to work out the 12th term in my pattern. So I know my formula is ARN minus 1. A is my first number, which is 10. My ratio was 3. To the power of 12, take 1. That's 10 times 3 to the power of 11. So if I do 3 to the power of 11 in my calculator times by 10, I end up with 1771470. Okay, 1,771,470 is my answer. And you can see that this formula is pretty simple and straightforward to use, isn't it? Because what you could have actually is, you don't want to be timesing forever, do you? So what you could have done is the 5th term, the 6th term, the 7th, the 8th, the 9th, the 10th, the 11th, and 12th, and you just keep timesing by 3, which is also a possibility. But that's not efficient, is it? It's not efficient, and it's not as easy and straightforward, because what if you had to work out, I don't know, the 25th number? You'd be there forever. Hence why this formula comes into use, and it's quite helpful in getting you to quickly work out the whichever term you need in your sequence. So this was a little background of geometric sequence to do with what geometric sequences are, and also you know, how to use geometric sequences in a problem which is not as straightforward as just working out the common ratio, etc. Hope this was useful. Thank you for watching.